Welcome to the Math Record. Today we'll be focusing on the parabola. This video will cover part 2 of chapter 5 in our Precalculus class. In this video, we will only cover the conics properties of parabolas. While a parabola is just a quadratic function, conics have few properties that delve into the concept of parabolas more in depth. So what is a parabola? Well, a parabola is a collection of points that are the same distance away from a point and a line. The point is referred to as the focus, and the line is referred to as the directrix. So imagine a graph like this, right? Sorry. Imagine a graph, and we have a parabola, right? There's going to be a point, and there's going to be a line. Whatever the equation is, this equation, these are the collection of points. The parabola is the collection of points. So any single point on this line is called the collection of points. So basically, let's say you just choose a random point, right? Okay. Whatever the distance is from this point to this point right here, which is called the focus, I'll label this as F, and the distance would be D. The point, and the point is P. The point from to the focus, the distance, is the same distance from this point to the directrix, which I'll label as D, which is this line, and it makes a right angle right here. So that's the line, and the line here. It doesn't look like it, but it is. So that's basically the entire concept of a parabola. That there is a line and there's a point in like around that parabola that basically says it's the same distance every single time. So there are basically four main cases where a parabola has like these kind of has this property. So well, all parabolas have these properties, but there's four main types of parabolas. So basically, there's two of them. One's like this, one's like this, and the last two are not even functions, which looks like this and this. So one opens to the left, one opens to the right, one opens down, and one opens up. These two are the most common cases. These two will also be introduced in the conic section. So how do you write these equations and find their properties? Well, basically, you could just use this chart that I made. So these are all the four types of parabolas. These are the vertex, these are the focus, and these are the directrix. And these are the general equation of a parabola. So if you just look at the picture for case 1, this is 1 for when it's open to the right. And the focus is right here, the vertex is right here, and the directrix. The directrix is right here, the focus is right here, the vertex, and the parabola is opening to the left. And this one's concave up and concave down, the most common cases where the directrix is here and the directrix here and the vertex and the focus. Do you see like the pattern? If you see the parabola and where it is opening up to, basically that's where the focus is going to be. And the opposite side is the directrix. So this is going this way, going to the right, so the focus is to the right. And the directrix is to the other side. And the right here is concave to the left. So its focus is to the left, and the directrix is on the other side. And it goes up, other side, down, and the other side. You see how these work? So basically, how you find these equations is like the vertex is h comma k. You could pause the video and screenshot this if you want. So basically, the vertex is always going to be at hk. And h is the x coordinate of the vertex, and k is the y coordinate of the vertex, which is right here all the time. You see the v. And the F would be representing the focus, is where it's going to be plus A. A is going to be some kind of number, and you can see it at different places. So if it's opening to the right, you're going to see it add to the x coordinate. If it's opening to the left, you're going to subtract it from the x coordinate. If it's from up, it's going to add to the y coordinate, and if it's going from the concave down, is subtracting from the y coordinate. So the directrix is basically from the opposite side. So whatever, if this is plus a, this will be minus a. If this is minus a, this is plus a. If this is plus a, plus minus a, and plus a. You see how it's the opposite sign all the time? So basically, if it's concaving up or concaving down, it's just gonna move from up and down, right? The directrix is just gonna move up and down. So you're just gonna change the y, because that's up and down refers to the y value. So that's how you think about it. And for left and right, you just gotta think of it moving right and left. So it's just gonna move the x coordinates. So these are just gonna move the x, and these moves the y. And these are the general form of the equation. So how do you tell if it's left or right? You tell it's left or right if you see the y term is the one that's squared. If it's the x term that's squared, like for these two cases right here, this side and this side, then you see that it's gonna be concave up and concave down. Because a regular parabola is y equals ax squared plus bx plus c. You see how the x terms are the one that are squared? So that's why that's the parabola. It's going up that way. So that's the regular parabola where the x term is squared. If the y term is squared, then it's going to the left or the right. And you see this. So just kind of screenshot this if you want. It's gonna be really useful. Okay, let's just focus on like some examples. So let's focus on example 1. X squared minus 2x minus 8y plus 25 is equal to 0. The first step you should always do is to get it into like one of these forms. So we have to get into a conics parabola form. So what we're going to do is that we're going to use kind of like completing the square. So basically we're going to have x, since you see this is 2, divide this by 2. So then you have x minus 1 squared. Because you want to, like, when you factor this out, this is x squared minus 1x. Then it's going to be, because it's going to be like this. So it's x squared minus 1x minus another 1x, so it's minus 2x. So you see how you get that minus 2x? So that's basically what you're going to be doing. So it's got x minus 1 squared. So whatever that term is, divide by 2. And then you just put that, then you put x minus 1 in that parentheses, if this one's the x squared term. So this only works if, because these are, you know this is going to be a parabola, because it's only going to be the x term that's squared. If it's also just the y term that's just squared, then it's going to also be a parabola. If there's an x squared term, like if it's x squared minus 2x minus 8y squared, then this is going to be a different conics. So make sure that like this is a parabola. It's going to be a parabola if this one is squared, if y is squared. It can't be both. Only one of the variables is squared. Only x is squared or only y is squared. So if it's a parabola, you do this. So you x minus 1 squared, right? So then you know that gets this term and this term. So, but this one also adds an extra 1. So just remember that. So you have an extra 1 here. So you have to subtract that 1 out, okay? So you have a minus 8y. We're going to move the minus 8y to the other side. So put equals to. So plus 8 from both sides. So you have 8y here. And you minus 25 to the other side also. So then you have this. This is the same equation as this, basically written differently. So then you have x minus 1 squared, add plus 1 to the other side, so you have 8y minus 24. And then you basically have x minus 1 squared is equal to 8 parentheses y minus minus 3, basically, right? So basically, whatever you have here, you want all the coefficient to be right here. So you want a coefficient right here. So if you see this side is the one that's squared, put the 8 here. Don't write 1/8 x minus 1 squared, which is the same thing. This is the same thing as this equation, but don't write that. Write the coefficient to the other side. And then what you're going to do is that you're going to take out a 4 from this number. So you have x minus 1 squared is equal to 4 times 2 times y minus 3. Okay? So you get this, which is basically, you just gotta look for these equations because it's 4 times a number, which makes sense. So 4 times a number times that linear term. So it's always gonna be 4 times a number times that linear term, unless it's negative 4. But it's not negative on that side, so you don't have to worry about the negative ones. So it's either this case, which is 4a, or 4a right here. So it's either the y squared term or the x squared term. And now we just gotta look at it. So it's the x squared term. So it's gonna be this equation right here. So it's gonna open up. So basically, that's what you're gonna look for. Let me move all this work up. Okay. So basically, this is the equation you get. So the second step after you get it into this form is that you have to have the x squared term right here on one side with no coefficient equals to 4 times some kind of number. It doesn't matter if it's not an integer. If it's a fraction, then let it be a fraction, times a linear term. And it has to be in parentheses, you know? So basically, what we're going to do is we're going to draw a picture. This is the second step. So we know it's an x squared term, right? And we know all these are positive. So this has to be concave up. You don't really have to draw the points yet. We're not going to draw the point. We don't have to make this as precise as possible. We're just going to draw a general outline of the graph. So you know this is concave up because it's the x squared term. So x squared would usually be a regular equation. So this is why, if you just think about it, if you reorder this in your mind, you don't have to be like really precise about it. So if you just like divide by 4, divide by 2, and then add 3, basically it's just y equals to like some kind of quadratic. So basically that's how you know it's concave up. Since none of these are negatives, then this is not negative, so it's not concave down. So this is concave up. So this is true. Which makes sense, because if you just look at the equation, it's just concave up. So now we just need to find the points. Basically, to find the vertex, I'll represent as v, which is right here. Let me make a circle. Right here. The vertex, the v, is basically just look at the x-coordinate and look at the y-coordinate. So the x minus 1, that gets you the x-coordinate, which is 1. And the y-coordinate is 3. So because if you plug in 1 here, that makes 0, and you plug 3 in here, it's also 0. So that's how you get the vertex. It's basically just that simple. Now you want to get the focus. Basically, what you do is that you look at the vertex, and you see where the graph is moving up to. It kind of looks like it's on the y-axis, but the equation is just not that precise. Okay, I'm just trying to draw a general outline for you, and it's easier to draw it this way. So basically, what you're gonna do is that you ignore the 4, and you kind of just look at that number that's multiplied 2. So basically, since it's moving 2 up, so you see the 2, it basically means it's going 2 up. If this is 3, it's going 3 up. So what it's gonna do is that you're gonna write the 1 because it's at the vertex, and then it's 3 plus that 2, so it's at 5. So that's basically what you do. If that's just basically 3, then you add 3, and that makes 1 6. If that's 4, just add 4 here, and that's 1 7. Okay. That's why you draw a picture for the second step. And then the directrix is basically the same distance, but at the opposite side. So now you see the directrix, which is a line, which is y equals 2. This is y is equal to. Because if it's a directrix like this, then it's got to be x is equal to. But you see how this is a line like this? Because you're not going to have a line like this. Because the line has to be the opposite side of a parabola. Because you just see the picture? Yeah, you see how it's like, if it's concave right or left, it's gonna be x is equal to. But if it's like right here, but if it's like concave up or down, it's y is equal to. See how it looks? It's just opposite side. Then basically, what you're gonna do is that you have y is equal to, you gotta find this number. You already have the vertex. The vertex is 1 3. So whatever the number here, you just subtract that number away. So it's 1 3. It's on the y value, so just subtract from the y value. So it's 1. 3 minus 2 is 1. So it makes sense because from the vertex, it's 2 away right here. It's shown right here. It's a 2. Add to the add the 2 to the y coordinate if it's concave up. So then you get the focus 1 5, and then subtract 2 away to get 1 1. That was kind of like equal distance, basically. So it's like 2 up and 2 down from the vertex. And you get these. So that's your so you got all the properties basically like that. So what you do is that you get it to this form. You draw a picture, and you kind of just get a sense of how it looks like, and you just draw the picture, and you just have the points. So that's basically how you do it. Let's focus on another equation. Let's say it's equal. Let's say we have y squared plus 6y plus 12x and minus 3 is equal to 0. Okay, basically. So what we're going to do is that we're going to do the same thing, divide this section by 2. So 6 divided by 2 is 3. So it's y plus 3 squared. So that gets the y squared term, and this gets the 6y when you just factor this out. And then you have an extra 9, so you have to minus a 9. Subtract 12 to the other side. Add 3 to the other side. Sorry, this looks kind of bad. You see how that works? So now this is equivalent to this. It's basically what I did on the second equation, but now with the y variable. So basically, add 9 to both sides. You get negative 12 is equal to plus 12 right here. And then you kind of take out the negative 12. So y plus 3 squared is equal to negative 12 x plus 1. You always want the coefficient in front. If it's in the parentheses, x has to be positive. So it's got to be x plus 1. It's not going to be negative x minus 1. I mean 12 times a negative x minus 1. It's going to be x plus or minus like some kind of number, okay? So basically, now you know this is negative, so you want to distribute that negative 4 out. But it's either going to be 4 or negative 4. Because you want the number to be positive. So what you're going to have is y plus 3 squared is going to be negative 4 times that number, which is 3. So you get negative 12 times 3x plus 1. So that's what we're going to have. Give myself a little bit more room. Okay. So that's basically what we have. So that's our first step. We gotta simplify it to a general equation. So we're gonna have. So basically, we're just gonna use one of these cases. You don't really have to think about like looking at the picture all the time. So what you're gonna do is that you have a y squared, right? So you know it's not gonna be x squared. So not one of the regular cases where you're gonna have like concave up or concave down like a quadratic usually. So what you're gonna think about is that it's gonna be either this one or it's gonna be this one. So how do I remember this? Is that if this version is, if it's not negative 4, right, and it's just 4, it's gotta be right. That's how I think if it's positive. If this is just x plus 3 squared, it's positive up. And then if it's negative on the other side, I just flip it to the other side. So if this is not negative 4 and this is 4, it's usually to the right. So I think the right is positive, and that's how I remember it. So it's negative on the other side. So it's gonna be concave to the left. So I know this is gonna be concave to the left. So that's how I'm gonna draw the picture. Oh, sorry. Okay. So right now we know it's concave to the left. So let's draw a picture out for that. Step 2. Try and draw like a really big graph, something like that. Okay. So we're gonna have to find the vertex. The vertex is always the same thing. So basically, wait, why do I write? Sorry, I don't know why I wrote 3x. It's just x plus 1. Okay. 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 Sorry, I kind of wrote a 3x for some reason. I don't know why. Now we have the vertex. So basically, in front of the x is the vertex. So you put negative 1. In front of the y is negative 3. So that's what you. So this is the vertex. Okay. So it kind of doesn't look like it, but just draw it like this form. Because basically, you just have to just draw the axes. Always draw the axes first, and then draw the parabola concave to whatever side it is. It doesn't have to be on the graph. Just draw it like somewhere, but it has to be on the right shape. Just draw the general outline, and then you find the focus. Since it's concave to the left, that means the focus has to be like somewhere around here. So what you're gonna have is they have negative 4, which tells us just ignore the 4 or the negative 4 ever. The negative 4 and negative 4, you just want to distribute out all the time. So those are the numbers we don't care about. But the number that we take out, that's the one that we care about. So this one's 3. So this one's moving at the x coordinate if you just think about it. Even if your picture is like up here, then you have your vertex right here or something, and you have your thing right here, you just know you have to move to the x, right? So you just have to think about it. So you have to move to the x by 3. So you move from here to negative. So negative 1 minus 3, negative 4. So you just have to think about the general position of where the point is going to be. And now you're going to have to get the directrix. So that's the vertex, and that's the focus. And now we need to get the directrix. The directrix is a graph. And you see how it's, since it's going this way, the graph has to go up like this. That's how it's going to be. So it's going to be an x coordinate. X is equal to something. So we have negative 3. And it has to be the same distance since this is like 3 away because it tells us it's 3 in this equation. what you have to do is they had to add 3 here. Since the x corner of the vertex is -1, we had to add 3 to that. So the direction is at x is equal to 2. And that's how you get it. So that's how you get all the points. You just draw a picture, get the vertex, focus, and the directrix. And that's how you draw the general outline. It's basically just that simple. You could do this case for like basically anything. So just when you have the equation, get to that general form, draw a picture, and think about it. Just think about it. Which general tips and tricks. Don't forget to distribute out that -4 or 4. If it's just like some number, like if it's a positive number like 12, then just take out a 4. If it's -12, take out the -4. If it's a negative number, take out -4. If it's a positive number, take out 4. Okay? And that number remaining is that distance away from the vertex to the focus and to the directrix. So distance here, distance here. So it's the same case. If the equation is this way and the distance is like 3 to the focus, then the distance here to the directrix, that's f, sorry, that's d, then it's also 3 away to the directrix this way. So it has to be on the opposite side. So just think about it. And that's how you get it. It's basically just that simple, which is the strategy that I use all the time. So overall, if you just want to memorize it, you could just also memorize it too. This is general form and it kind of works all the time, basically. That basically covers like the main points for what you need to know for parabolas in this class. Anyways, thanks for watching and I'll see you at the next math record.